When I was growing up, I excelled in math and sciences. By default, I was always encouraged to pursue a career in engineering. But upon reaching my freshman year of college, I realized that I didn't have a clear idea of what engineers actually do. As it turns out, my classmates didn't either. College students are required in or after their freshman year to select a specific engineering major. Selecting one requires students to understand the day-to-day operations within their respective field, something that most university students lack before making such important decisions. It is crucial to introduce interested students to a wide variety of STEM concepts before entering university and convey the day-to-day operations of specific fields. Howdy, my name is KJurecka and I am a junior civil engineering student at Texas A&M University. Today, I'm going to share my research experiences under Dr. Stacy Lyle from summer 2021 and how they have led to the development of STEM-based educational modules. These modules aim to increase the availability of STEM education content and introduce students to highly technical concepts at an earlier stage. In essence, we hope to bridge the gap between knowledge and application. Texas A&M is home to the Corps of Cadets, one of the largest uniformed bodies of students in the nation. Historically, the Corps of Cadets and non-uniformed Aggies alike have served our nation as military and community leaders. As such, thousands of former students are buried in our nation's national cemeteries. Because so many paid the ultimate price, we don't want their stories to be lost. Our research group at Texas A&M partnered with the National Cemetery Administration's Veterans Legacy Program to conduct a transdisciplinary approach to extend the memorialization of those interred at the national cemeteries. We call it the Aggie Legacy Project. In collaboration with Klein Independent School District students and faculty, we built and tested a web application headstone collection tool, developed 3D interactive maps of the Houston National Cemetery, and crafted biographies of former Aggie veterans to be recorded through the Veterans Legacy Memorial website provided by the National Cemetery Administration. These research initiatives were highly technical in nature, and we noticed that there existed a gap in both leading educational content for the National Cemetery Administration and in today's K-12 education. Many STEM disciplines lack adequate representation in K-12 curriculum. Therefore, students do not have ample opportunity to explore potential career paths before college. In addition, students in rural areas often do not have access to advanced STEM education due to a lack of resources. To combat this issue, we developed a set of modules designed to break down these complex topics that we use to fuel our research in the Aggie Legacy Project. These module topics include Geographic Information Systems, Unmanned Autonomous Vehicles, Global Navigation Satellite Systems, Geospatial Databases and Analytics, Historical Research, and Field Data Collection, all at a level to be understood by high school students. What sets our modules apart is not only their content, but their interactive nature for students. We worked directly with students at Klein ISD to learn from them how they learned best and what content and methods were most engaging. The modules are self-paced, require engagement through activities, test knowledge progressively, and provide a certification at the end. Especially noteworthy is the inclusion of experiential learning labs within the modules. Experiential learning is all about learning by doing, and my peers and I in engineering courses all agree that we learn most effectively when we get to do hands-on activities. In these module labs, not only do students receive instruction, but they have the opportunity to make connections to real-world applications of their new skills. These labs are designed to emulate the basics of what a professional in that field might do in their day-to-day operations. In addition, sub-modules have extra optional slides that go even deeper than the required content for those students who are especially interested. Our modules are designed to be easy to share and developed for continuous and quick improvement as content and needs change. They can be used by students alone or in collaboration with instructors who can help students when needed and provide feedback on labs. Now, let's take a look at an example module. This is a quick overview of Module 1 Geographic Information Systems. Each module starts out with a title slide that explains the content of the module as well as a section-by-section breakdown. After the welcome slide is a quick course navigation video for those students who have not completed a module before. Also, there is optional audio to go along with each slide for students that need extra accessibility features. The modules are easily navigable with a menu on the left-hand side. Each section starts out with a title slide describing the information to be covered within the section. Slides are a combination of text, images, videos, and interactive content. Slides can either be free to navigate or locked so that students must complete them in a specific order before proceeding. At the end of each section is a brief quiz so that students may test their own understanding of the content. Students are not penalized for incorrect answers, but are led to the correct one. At the end of this module is an Experiential Learning Lab. The module covers the basics of the lab and then links are provided to the outside lab for students to complete. At the end of the module is a final quiz in which students need to obtain a passing score of 80% or greater in order to obtain their certificate of completion. This module's lab requires students to build a 3D headstone, much like the ones that we used for the Aggie Legacy project. The lab starts with a brief explanation of the lab itself in addition to the ABET and TEA requirements that it meets. The lab first instructs students of how to download the software before guiding them step by step on how to use it to create a basic headstone. Here's an example of what a headstone that a student would design might look like. It is our goal that these modules and labs promote multimodality learning to improve students' knowledge and skills within the STEM field. We hope that by introducing this content at an earlier stage in a student's education will help provide clearer direction, improve quality of STEM leaders, and even reduce risk in the long term. These learning modules have the potential to improve STEM education and awareness before university. Students can become even more confident in their decisions regarding choosing a career path. It is my personal hope that we can keep students from the same experience that I had, wondering, what do engineers actually do? Thank you.